You got something different.
Yeah, it's ry minus 4 over t minus 2.
Ry minus 4 over t minus 2 equals x.
Yeah.
Who got the same thing with Leo? Who got a different thing from this? Andrew?
Maybe.
Who is with Andrew?
I haven't got a T in that at all.
Okay, that's okay. So what about number 7? Okay.
I got x equals 5 over 3 minus a minus 2.
As a plus.
X equals what?
5 divided by 3 minus a minus 2.
Okay, who got the same thing? Okay, so after you got the same thing. Any other person? Did any of you get this a different answer? Okay. What about number 8?
I got x equals w minus c over 4, sorry.
W minus C over U over 4. Who got the same thing? Okay. What about the last one? The last one. The last one.
I got x equals t plus 8 over d.
Okay. S equals 8 plus t over d. Okay, so let's find the solutions to all of this. Remember, we are in type 1, which is equations without fraction. How to make anything the subject. Right? So let's find the solution to this. So, number 5. Solution. So for y, we have y plus b equal to x, right? Because to eliminate b here, you have to add b. If you have plus b here, I have to do the same thing here. You have minus b. That's how we got this. What about number 6? Number 6. We have y minus 4 equal to tx minus 2x. Do you know how I arrive at this? Do you know? It seems like all of us don't know. So look at the idea. You want to make our problem simpler. And now, what we want to do is, since we are making x the subject, but we have x in 2 different terms. You have x here, and you have x here. So we want to find a way to make x come together. It's more like using the mindset of collection of like terms. But this time, this is not an expression. This is an equation. And whenever you are collecting the like terms, or grouping the like terms in equation, and anything happens and you are crossing a term, any variable with coefficient to an equal sign, whenever it crosses to the other side, the sign has to change. If it's an addition, you have to change it to what? A subtraction. If it's a subtraction, you have to change it to addition. Look at what I did here. I have ry, and I want to bring 4 to this side, because I want all the x to be in one side. That's my m, right? I want to make my problem simpler. Let me just put x in one side. Then after that, I'll think of what to do. So putting x in one side of the equation now, I have to bring the 4 to this side. Since you have plus 4, and it crosses this sign of equality, changes to what? Subtraction. And if you do the same thing here, 2x, I want it to come and meet this tx here. So that I have x in one side. So I will know that. Let me think of what to do next. When I bring it to this side, addition crosses, it changes to subtraction. That's how we arrive at this point. So what do you do next? You factorize. Remember the law of distributive property of number, which says that if you have, oh, this is it. If you have this, now this is what we have. We want to factorize this. What do they have in common? They have a in common. You can factor it out and make a to be outside the parentheses. You see that mindset of this property of a number. You have x here, You can bring out x outside the parentheses. Right? Very very straightforward. You have ry minus 4 equal to x into t minus 2. Correct. You can see that our problem is getting simpler and simpler and simpler. Now, what do I do next? I want to eliminate everything here. And what do? I want to divide. You know, the last one we did like division, it was like only a variable. So whether everything is like this, once everything is like this, you can actually divide through everything. I want to divide everything by what I have here. You can call it the coefficients. Right? So at this point, you can use the language the coefficient. I know that I told you that coefficient is the number before the variable. So at this point, it's more like using a kind of a partial mindset. At this point, if you're making any subject, so just treat this as a coefficient. Right? So if you divide this by this, everything will go out. You have x. And if you are doing it in this right hand side of this equation, what do you do next? What do you do?
The other side.
I'm doing the other side, right? Good. So I have to also divide this side with the same thing. This will cancel out. Hence, you have ry minus 4 over t minus 2 is equal to x. As simple as that. Good. What about number 7? Who got this? Someone got this. Did any of you get this? Did any of you get this? Correct. Okay. Number 7. You do the same thing. You have 3x. You bring this one to this side. You have 2x equal to. I have x in 3 places, right? I have x in 3 places. So 3x minus ax minus 2x equal to 5. Then I have everything here. I hope you know that this distributive property works for more than 2 variables. It's not a word that you have more than 2 variables. You can have this, everything here. A into bracket B plus C plus D plus E plus F plus Z. Now everything has to be what? A, B, A, C, A, D, A, E, A, F, and A, Z. So if you're having something like this, and x is here, x is here, x is here, and they have the same degree, raised to power 1, you can factor out x to have what? X will be outside. You have 3 minus a minus 2 equal to 5. Hope this is clear. Hope this is clear. Because we know that this distributive property, whenever you have this, that you can factor out to get this. Now we are thinking of this in a bigger way. So if you have more than 3 terms, you have the first term, second term, and third term, and across all the terms, x is common. You have x in all of them. What do? You factor out the x. What next? What do you do next? You divide both sides with coefficients. Divide both sides with what we have here. Divide this a minus. Is this 2x? This is 2x. This is 2. Let me even tell you something. Do you know why mathematics is wonderful? I can decide to bring this together. 3x minus 2x will give you x. Right? So you can do it at this point. Or even if I forget, just like I did now, and I decide to do it at this point, it's still okay. I'll still have everything divided. So here you have 3 minus a minus 2. This will cancel this. Hence you have x 5 3 minus a minus 2. Hence this is equal to x equal to 5 over 1 minus a. Is that correct? But I could have, since I have a number here, I could have just done 3x minus 2x. But it doesn't matter, you still get the same thing. Is that correct? So, what about number 8? So, number 8. We have 4x plus c equal to w, right? Just like we have been doing. To eliminate this here, you have to subtract c. If you do that here, we subtract c here also. Hence, you have this, you cancel this. You have 4x equal to w minus c. You divide both sides with coefficient. This, you cancel this. Hence, you have x equal to w minus c over 4. Then the last one is number 9, which is dx plus t equal to 8. What do? You have to eliminate this to make our problem simpler, right? You subtract t. You do the same thing here. This you cancel this. Hence you have dx equal to 8 minus t. You divide both sides with coefficient of x. This. Hope we all, this is very clear. We all can now make any variable the subject. So far is an equation involving an equation without fraction. A linear equation that has no fraction. Something like this. This is type 1. Now type 2. Type 2. Equation involving fractions. Type 2. Equations involving fractions. So the first one, want to make is the subject in this. Okay, example 1. Want to make H the subject. V is equal to 4 over 3 pi r squared H. So want to find H. Want to find H when V is equal to 20, R is equal to 5. Well, let's solve the first part first of making H the subject. This will come after you have made H the subject. Only what you need to do is only to substitute the value of V as 20 and R and as 5. You are plugging in these values inside our equation. Right? So to make H the subject, solution. Anyway, let's write everything out. Some example first. So number 2, we have x t equal to v plus d over 2. And you have to what? Find d. You are making d the subject when let's just find d. Let's just make the subject first and leave the plugging in. 3. giving y over x over y minus x over v minus x equal to y over v squared. You want to make y the subject. Consider that sometimes the languages differs. So find D, find H is same as make H the subject. It means the same thing. And also, number 4. 1 over t equals 1 over n plus 1 over y. Find n. Find n. Number 5. This is number 5 here. Y is equal to 1 over 4 u x plus 3y x. Want to make u the subject. Find u. So these are equations involving fractions. Equations involving fractions. Where is the Let's solve more examples. Let's solve this first. Please, can someone help me with cleaning this side? So, we are done with the first one, equations without fractions. Now, for equation involving fractions, what do? You are using that same mindset that whatever you have close to the variable that you are making the subject, you have to eliminate that. And you have to think of what will you do to eliminate that. And whatever you are doing to that particular coefficient, the number close or the variables close to that particular variable you are making the subject, you have to apply the same thing in the other side of the equation to make it balanced. Right? So, where's my marker? So, for the first one, solution. First one, we want to make h the subject. I will have this v equal to 4 over 3 pi r squared. H. What do you do first? To make everything simple. Let me eliminate what I have here first. 3. What do I do if I want to eliminate what I have 3? I have to multiply here with 3. Right? So if I say times 3, that means 3 will cancel 3. 3 divided by 3, it will be out, right? If I do times 3 here, I have to multiply it by this also. And if I do s times 3, it will be what? And v times 3 will give you 3v. You have 3v equal to 4 pi r squared h. Now I have a simpler problem. Everything is now like linear. There is no fraction. Remember, we are making h the subject. Everything here. What if I divide everything? If I divide this with this, it will go out, right? I have 4 pi r squared. If I divide everything with what? 4 pi r squared. I have to apply the same principle in this left-hand side of the equation, right? So if I do that, I have 4 pi r squared. So this will cancel this. Hence, you have 3v over 4 pi r squared equal to h. This is our h. Now, what do we do next? We have done the first part of the equation. If this is an exam, we have just done the half. You'll be getting like half mark. The next thing is you'll be applying whatever you have here. Because we are giving the value of variables. Remember, we said that variable is a representation of unknown values. Now we now know the value. The value is 20 for v, and the value is 5 for r. So we are plugging in 20 and 5. So wherever we see v, write 20. Wherever you see r, write 5. Plug it in. Right? So from here you have 3v. What's v? V is 20 over 4 pi r. R is what? R is 5. 5 raised to the power 2. This 5 raised to the power 2 means 5 coming 2 times. So when we get to indices, you understand the concept better. That's why I'm doing all this illustration, making sure I don't go overboard. I don't go into solving higher polynomials like raised to the power more than 3. Right? So for now, we'll be solving variables that has only raised to the power. That's what it will be over maybe highest 4. Right? So this is equal to h. 3 times 20, 60, divided by this. Just do this basic operation and tell me what h should be. Do it with your calculator. You have a calculator, right? You can use the scientific calculator in your phone. I know I use.
No?
No, I have a calculator. I'm just saying. I have a calculator. I have like 2.
0.191.
I have Texas Instrument and I have Casio. So, what did you get?
0.1909859317.
0.
1909859317.
Okay, so this is your answer. At the same time, you can decide to leave your answer in 2 decimal places. It means like it will be 0.19, right? Or you can leave your answer this way. It's still correct. But mind you, whenever you are leaving your answer in any way, maybe 2 or 3 decimal places, make sure that the number after that particular last number you are writing out, if it's up to 5 and above, you have to add 1 here. You all know that, right? If it's less than 5, you leave it that way. Right. And again, most times you can say, this is approximate. It's not equal to, but something like this, 0.19 for 2 decimal places. This is equal to h for 2 decimal places. For 3 decimal places, you say this is equal to 0.191. Because this is more than 5. This is 9. Yeah, this you have 1. This is approximately equal to H. But that's okay. What about the next one? Number 2. We have x over t equal to v plus d over 2. Over 2, right? What are we making the S? What? Okay, we are making D the subject. We are making D the subject. Good. So first of all, let's eliminate all the fractions. Let's just do away with the fractions. And how do we do that? I have to multiply by 2. If I multiply by 2, hence you have x over t equal to v plus d. D over 2. Multiply by 2 here. 2. You have to do the same thing here, right? This will cancel this. Here you have 2x over t equal to v plus d2. Good. What about this? Let's multiply also by t. Let's multiply here by t. And also do the same thing here. By t. Hence you have, this one will cancel this. You have 2x equal to v plus d. You have 2t here. Now we have a simpler problem. Okay, you have a question.
Wouldn't it just be, wouldn't the 2 already divide itself out, so it'd be 1? So wouldn't it be v plus d t instead of 2t?
Wait.
Because when we divided by 2 on the second step, shouldn't that just get rid of the 2 above it because it becomes 1?
It becomes 1. Thank you very much.
Yeah.
Thank you very much. That means you are following. Good. When did I manufacture the 2? Okay. You are correct. Thank you very much. So, 2 divided by 2 will give you 1. Hence, you have 2 here. You have only t. No, we don't have anything here. Hope this is correct. Hope you followed. How many of you followed to this point? Or okay, everyone followed to this point. Good. So, we are not making t the subject, we are making dt. Now look at what we do. We use this t to distribute into these terms that we have inside this parenthesis. Right? Hence you have 2x equal to vt plus dt. Good. What do you do next? Since this is having d, and that's what we are looking for, you have to eliminate what you have here. You subtract dt, you subtract vt. If you do that here, do the same thing here. You have 2x minus vt equal to dt. Is that correct? So at this point, you divide both sides with the coefficient of d. So to eliminate this t here, so that d will be standing on its own, that means making this subject. Divide this by t. Right? Left hand side of the equation. You do the same thing in the right hand side of the equation. Good. Hence you have 2x minus vt over t equal to d. Correct. Oh, we are not giving any value. That means this is a final answer. But I didn't mean we are giving the values of maybe x, vt, and we are asked to substitute. We only need to plug in the values, and that's all. Okay. What about the number 3? Can we try out number 3? Let's try. Then we can solve it all together. Let's solve in 2 minutes. Not individually, you can interact within yourselves in group of 3. Interact and talk about the steps and what you need to do at 2 o'clock. You are free to interact, share ideas, work in group of pairs. For number 3. Okay, so let's go on 8 minutes break. Let's come back after 8 minutes. Let's come back by 10:14. 8 minutes break. Thank you.
Oh man.
new shirt.
Thank you,
This is
sir.
a nice touch.
No.
I'm about ready to be done. Thankfully, I'm checking out.
Look at that one. Yes. You know that one
On the way. Later. Yeah, I'm always going to express. Yeah, we have a lot of like,
Yeah.
yeah, so. Yes. And then we have all of this
I got 2 more semesters.
I've already gone through it, so.
What's your name? We should get an extra 20 times. I feel like how many? 30
Where's that from?
Apparently true.
Okay.
I think the last one was like culture when my ancestors came to the United States. Yeah.
I have some consensus.
Oh, yeah.
So, what did you switch from?
Dude, it's going great. We're at hour 2.
It was the fun class.
Getting a little bit nervous. The AM is the 4
And I think,
good so far.
That was enough.
I was asked
Science right now.
all the other computer science classes were just like, okay. It wasn't very like invigorating or exciting. I was just doing it just because it was computer science. And I thought, oh, a lot of job opportunities or something. After I had that class, I absolutely hated it. It's probably going to be more like this. And for a major, I don't even really care that much about. There's still a lot of especially for like analyzing data. Use Python. Say long at least it's not like is that one problem? Are you doing that for your linear algebra?
Yes. So it's a new linear algebra base. It's a new basis lines. How we do it.
I was about to ask, like, okay, what are you doing it for the computer?
And so like I so I have to do a lot of this how to
Like sarcastic. It's so funny because I was going to pick like foundation. Well, I could just go up to it and be like,
Hello. Welcome back. So you are free to eat quietly and listen while we continue. Is that okay? Is that okay? Perfect. Okay. So for number 3, we are making y the subject, right? First of all, we want to eliminate the fraction. To eliminate the fraction, here we have y minus x over v minus x equal to y over v2. We have y in 2 different places. Our aim is to bring y at least to come together, right? So here it was multiplied in the sense that we want to eliminate what we have here. You have to multiply this with what? V squared. And you have to do the same thing here. In this side of the equation. This will cancel this. Right? Hence you have y minus x v squared over v minus x equal to y. What do we do next? This will come to this side. You multiply the numerator here with this. Hence you have v minus x here. Also have v minus x here. This will cancel this. Hence you have this again. Y minus x v squared equal to y v minus x. Is that correct? Now we use v squared to distribute into this and this. I'll use y to distribute into this and this. Hence you have v squared y minus x v squared equal to v y minus x y. Right? So what do we do next? We want to bring all the y's together. All the variable that has y, I want to bring it to one side of the equation so that it will be easy to factor out y. Is that clear? And if we do that, you have here you have v x y. Come to this side, change this to what? Subtraction. minus vy. Here we have plus x, y. This one go over to this side, equal to x v squared. Since we have y here, y here, y here, we factor out y. Hence we have y into v squared minus v plus x equal to x v squared. We will divide both sides with the coefficient of y. You divide this side with y, divide this side with y. Divide this side with the coefficient, which is everything we have here in this parenthesis. We have v squared minus v plus x. Hence you have v squared minus v plus x. Everything here will cancel everything here. Hence you have that y is equal to xv squared over v squared minus v plus x. Right? Good. What about the next one, number 4? For number 4, we are making n the subject. Right? We are making n the subject. So whenever you see something like this, you do what? You find the LCM. And we have 1 over t equal to 1 over n plus